Good afternoon. Hello. Hello, everyone. Welcome to SIG AWS Update. My name is Justin Santa Barbara. We had a couple of AV snafus, but I was saved by this wonderful gentleman, I think, when I took a knee. So if anything goes wrong, well, I will once again get down and pray to the AV gods. I might actually have to do that. Let's see. Oh. See, the prayer worked. Okay. So I was just going to give a quick overview of what we're going to cover. Basically, a general state of the SIG and what are the things we're working on. The thing which I think is most exciting, either or both for people working on AWS and as users of AWS, is the general move to multi-repositories and what that means. And I want to save a lot of time for Q&A or open discussion, because I think that our community is what makes AWS and Kubernetes such a great ecosystem, and I encourage you all to think up some questions so we have something to talk about at the end, because this shouldn't take the full time. For those of you that don't know, there are three leads of AWS. Chris Nova, who I don't see here. Bob Wise, if you'd like to wave or stand up, that's Bob from AWS. Chris works at Heptio, and I recently joined Google. So we're the leads. We also have Nishi here, who is also at AWS. So if you have other questions about AWS stuff, you can go and find them. And of course, Chris is around the conference somewhere, and I'm around as well, wearing a very recognizable blue sweater. Cool. So what are we working on in AWS in core? And I want to make that clear that this is in core, because what's coming is a little bit better. So what we're working on in core is a little bit of support for NLB, the new network load balancers, or newish network load balancers, and support for NVMe. So that's just some minor support for the new volume types that offer higher performance. So not a lot, right? And I think that's a great thing, because what's happening out of core is a lot more. So we have a ton of stuff happening outside of core. So we just did our first SIG repository, the AWS encryption. AWS cheers, whoops, well, I know it's a lot, but yeah, the AWS encryption provider, which is about using AWS KMS for encryption of data at rest in etcd. So it's been a persistent issue that secrets in etcd are not encrypted, and this will enable that to be encrypted using secrets stored in KMS. The authenticator, so Heptio have been working on an authenticator that will let you authenticate to your cluster. So kubectl authentication, effectively using your AWS credentials, so probably your access key and secret key. And I believe that they are working on contributing that into the Kubernetes SIG repositories area as well. AWS are working on a VPC CNI networking provider, so a CNI provider that's really optimized for running on AWS, on VPCs, that essentially uses ENIs. More applause, this is great. That essentially uses network interfaces to assign a real AWS IP address to each pod. So your pods become sort of first-class citizens on your AWS VPCs. ALB support, so ALBs are the other load balancer, and this was developed outside of core. There are actually two projects that implement ALB today. There is one from Core OS and Ticketmaster, and one from Zalando. They're both great, but I think AWS are actually evaluating the different options and are going to make a proposal for what we should do in the SIG as sort of a more official recommendation. And EBS driver support for CSI, so the container storage initiative. So about being able to interface, thank you. The container storage interface. So adding support for that for EBS volumes. So this is a ton of stuff that's happening outside of core, and I think I have we'll talk a little bit more about why that's happening, but there is a lot happening, and it is happening outside of core. The other thing that's happening in terms of moving things outside of core is the Cloud Controller Manager. The good news is that this is not something that should impact you as a user. And even as a developer, it shouldn't impact you in any particular negative way. The idea is that currently there is a component that runs on the master called the kube controller manager, which basically aggregates a bunch of controllers, the controller loops that form all of Kubernetes, and it combines sort of there's a controller for deployments and one for replica sets, and there are also ones that are more cloud specific. So there's one for services of type load balancer, or services of type load balancer, and there are also ones for volumes. And so the idea is essentially that we want to split that code out of core into separate modules, separate Git repos. And the reason for that is because that doing everything in core has become very difficult. It's a lot harder to work in core as a contributor. It's a lot harder for the maintainers to maintain everything. And looking around, there's not just AWS and GCE and Azure anymore. There's an increasing number of clouds that want to get more and more functionality in, and it would be great to be able, for each of those clouds, to be able to work on a separate lifecycle and on sort of managing things their own way. And this isn't a sort of punishment for AWS or anything like that. It's happening for everyone. So even the GCE cloud provider is being moved out. So the core of Kubernetes will be very much the very generic objects like the pod. I think everyone agrees that the pod is a core Kubernetes concept. But beyond that, I think there's some debate about what is in and out. But we're going to try to make the cloud provider interface, pull that out of the Kubernetes repo into what will probably be AWS-Cloud Manager, Cloud Controller Manager. And the idea is that then when I introduce a bug in the AWS code, that we can fix that very quickly without having to go through a full release of Kubernetes, which is the situation we're in today. So from the user point of view, you shouldn't really notice any difference. If you're installing your own clusters, you'll have to install the Kube Controller Manager and your relevant Cloud Controller Manager as well, so a slight difference there. From the user point of view, you shouldn't notice any difference at all, except that everything sort of works a bit better and you get your fixes faster, and that generally the project is healthier and moves faster and more reliably. So healthier project. So generally there is a working group that is working on this process, and I believe they're starting the cutover process right now. So I think you'll see a freeze in the sort of core cloud provider. So that's why it's such good news that not a lot is happening in core, because we're going to have to stop that for the duration of the cutover period. So as long as it isn't why I said staring and not starting, yes. It is an execution split also. Currently the Kube Controller Manager has all these separate controllers, and the ones which are cloud provider specific will move into a separate binary that will run presumably in a separate pod. Probably it'll be as simple as a daemon set tainted to your masters, or tolerating your masters. So it should be a pretty easy deploy. AWS is here. Yay! So we've seen an increasing amount of AWS participation, obviously. We've seen AWS employees contributing to open source and participating in the community, and apparently they're hiring, so that's great news. They've joined the CNCF, which is wonderful, and I think the product is EKS. I don't know if we have a timeline update or anything you want to say about that, but it is sort of real soon now, and it is certified Kubernetes. We passed the conformance test, which is wonderful. And so it's also great to see AWS taking a leadership role on a lot of those efforts that we talked about the stuff happening outside of core. So thank you and welcome. The SIG AWS organization, we have a bunch of sort of housekeeping type things that we have to do. So we're working on, or Bob is working on the charter. We are likely to clarify the leadership a little bit. Probably other SIGs are splitting the organizational leadership from the technical leadership. So we'll likely have, I think they're called tech leads and chairs, is I believe the term other SIGs have used. So we're looking at that sort of process. So if you'd like to consider yourself, or to be considered, or to nominate yourself for a tech or organizational leadership position, then please speak up and get involved. And SIGs also have a stronger notion now of code ownership. So we have to declare the code that we believe that we own as a SIG and are responsible for maintaining and are on the hook for if something goes wrong. So we have a bunch of admin type stuff, boring admin type stuff, and the reason is that all this is sort of the carrot that we get for all of this is that there are now 3 types of Kubernetes projects. So they're the core projects, the ones that are the sort of more tightly controlled, very tightly scoped small projects. There are SIG repositories, which are owned by the SIGs, and effectively anything that is relevant to SIG AWS. SIG AWS can go through a relatively easy process and get created as a SIG repository now. And that lives in github.com/Kubernetes-SIGs, and then the name of the project. So AWS Encryption Provider was the first one of those. So it's github.com/Kubernetes-SIGs/AWS-encryption-provider. And so that, and the third type is associated projects, which, if, for example, if you wanted to create a project in your own organization at GitHub, but you wanted to think about maybe contributing it later, it is much easier to do that if you are an associated project. An associated project essentially follows the code of conduct and uses the CLA. So essentially we have clear code provenance if you ever wanted to contribute it to Kubernetes. Of course. And it needs to be Apache 2 licensed. Yes, sorry. Apache 2 licensed, CLA bot, and code of conduct. And then, of course, there's no, you obviously can, Kubernetes has a very wonderful API, so there's nothing stopping you building a project that is not in one of those 3 camps. Don't feel like there's just some sort of requirement for your own things. There is the very memorable URL. These slides will be available in the links, but you can also just probably search for SIG repositories. But I think this is actually like the most exciting thing to happen to Kubernetes as a whole, because previously it's always been a bit hard to know, how do I actually get going and contribute code to Kubernetes? Where does it live? There's always been a pushback against, like, should this go into the core? Do we want to maintain this? Now we have this very clear location for projects that are particular to an individual SIG, and it's a relatively streamlined process and easy to create them. So the reason we have that wealth of projects that are being created outside core, the encryption provider, the ALB, the other ones, the authenticator, is because of this new process. So the admin stuff is going to feed into this, and I really am excited. And if you have projects that you think should happen on AWS, but maybe in the past you felt that the barriers to entry were too high, or that maybe didn't belong in core Kubernetes, and this applies to any SIG, then do go to the SIG and propose it and see if there are other people that agree with you, and get your project going. And it's a wonderful place to contribute. But obviously this creates a world in which our code now lives not in one repo in Kubernetes, but now is going to be spread across at least dozens of repos. To an extent, this has been true anyway, but we're really going to have to grapple with this going forwards. It does mean we have much faster development outside of the core, and in return that the core is much more stable. And the core has been doing a ton of work to actually enable this. Sort of an anecdotal example is the encryption provider. GCE's encryption provider was originally done in core, and then the debate came about, like, well, when we want to add Vault, and we want to add AWS, and we want to add Azure, like all the different plugins, and rather than add them to core, what they actually did was they kicked the GCE one out of core, and they added a gRPC interface. So I thought that was actually a really powerful statement of the extent to which they are serious about, like, this being the new way of operating, that the core will have well-defined interfaces, and any provider can come and implement those interfaces. It does create some very interesting challenges around the release process. Like, what is a Kubernetes release? What does Kubernetes 1.12 look like when it pulls from 50 different repos? And is the GCE cloud provider considered part of the release? So, and how do we sign those releases? All these difficult questions, and so if you're interested in those sort of things, I think SIG release is driving those sort of questions. But interesting times and exciting times, but also some challenges. If you are excited about hacking on something, I am doing a little experiment tonight. So one of the things I think would be cool is if we had more, sort of live casts hack sessions and participations, and the mentoring program has been very successful. So what we're going to try, if anyone wants to come along at 8:20 tonight, which is pretty late, is if you want to come and try to get like your first PR in, or want to talk design topics or something like that, then come along and we'll figure out based on the numbers what we can do. I was imagining not many people would show up and we'd do a lot of sort of one-on-one pairing, but a lot of people have RSVP'd, so we'll see what happens. But the goals are get your PR merged, face-to-face design and code discussions. If we get past a scale where, if we get to the scale where that doesn't really work, then we'll have to maybe call on volunteers to come up and have their PR publicly reviewed. So we'll see. But yeah, that's a bit of an experiment. We'll see what happens. But I think that feeds into the idea that, you know, this is a great time to contribute to Kubernetes and contribute to the AWS code, and so do consider it. And yeah, that's all I actually wanted to talk about in terms of what was actually happening, because I wanted also to save a lot of time for Q&A. I hope we have questions. Great. I can either give you the mic or I can repeat the question.
Thank you. So I'm kind of new for this kind of topic, but I have a question. With all the repositories, are you going to do some testing against the different versions that are going to be released?
That was the other thing, as well as like, yes, we have to figure out how to do end-to-end testing across. So yes, that is exactly the problem. And I don't think we have an answer yet as a community. I think one way to do it would be to, we're certainly going to have to, we have end-to-end testing, for example, of kops, which lives in another repository and has a quite complicated mechanism to like pull in different, like we test the head of kops against the last stable of Kubernetes, and we test the head of Kubernetes against the last stable of kops, which works with 2. I don't know what happens when you have 50. But there has to be some way by which a user knows that this set of things has been tested and considered of good quality, and it's not yet clear whether that is Kubernetes that provided it or whether that is, you know, Google and AWS and Red Hat that provides it. But I hope that we can do something as a community where we still have a release that has a set of artifacts. But on the other hand, like half the joy of doing it in different repos is that, you know, you're not tied to the release process and you can do a fix independently. So it is definitely a challenge to ensure quality and testing at the same time as this. Yeah.
Okay, so sorry. My question is about separation of execution of the scheduler. Is that mean that the Amazon users will not have any Google scheduler code inside their clusters?
Yeah, so it's there are actually three components today that live on the master. There's the API server, the scheduler, and the kube controller manager. And the scheduler largely is independent of the cloud provider. In fact, it doesn't call into the cloud provider at all. The exception there is volumes have labels which indicate the zones that they're associated with. And those labels are added by the cloud provider, but they're added before it gets into the scheduler. So the scheduler will continue exactly the same. It will take as inputs some things that have been done by the cloud provider, but the kube controller manager will be, yes, the kube controller manager will itself be the kube controller manager will have no cloud provider specific code in it at all. And then the AWS cloud controller manager, thank you, will have only AWS code and will not have a GCE or Azure or binding, and similarly the GCE one will only have GCE code in it. Nothing stops someone from doing the Uber cloud controller manager if you wanted to. Like this isn't a requirement, but in practice I expect each cloud will have their own, and that'll probably be a bare metal type one, right? But each cloud and bare metal will have their own cloud controller manager that is specific to just the stuff that is relevant on that cloud. Yeah, it'll be interesting to see. No, my understanding is no, it will not be removed, but the controllers because there are controllers in there that are in kube controller manager that are not cloud provider specific, and we're going to keep calling that kube controller manager. Examples of those controllers are like the deployment controller, which creates the replica sets, and the replica set controller, which creates the pods. So that one is pretty core and will stick around.
I have questions. So right now, AWS is quite restrictive, and it basically requires you to create your infrastructure in advance and only then create cluster. So one example of it is tagging the public subnet with cluster name. Another example is creating VMs and then generating certificates. Are there any plans to do it different ways, so I can prepare some template, something, and then deploy any cluster I want and don't care about creating infrastructure or thinking, okay, this is, I need to tag this load balancer, I need to have those VMs with this name, and I need to sign certificates specific way late after I created them.
I don't know if you're talking about so there are some requirements done by the AWS cloud provider, which are across all the instances of Kubernetes, like the cluster ID tag, for example. Your installation tool may also put network restrictions on. I don't know if you're talking about EKS or what's another. Can you give let's do a concrete example.
So, concrete example, I want to create 5 clusters.
Yes.
In order to, and I don't know their names, I don't know anything about them. So in order to create load balancers, I need to tag them tag public network after I create my clusters. This is one example. And second example, I create my cluster. I generate certificates generated by different tool. I don't care about them. But in order to generate certificate for kubelet, I need to basically know the name of the node before I have certificate.
Yeah. So. Yeah. So it's hard. I don't know that some of those things are not going to be that much, like the name, having to know the name to put on your certificate is not going to get much easier in core Kubernetes or in Kubernetes itself, but I mean, EKS is going to be a solution that will make it turnkey. Kops is a solution that makes it turnkey. I think the reason why is that I think what we should do in, I don't want to call it core anymore, but in the main open source project, is to figure out what those problems are and how to address them. For example, so if you created a load balancer, an ELB, that would give you a stable name for your API server, and so that's one of the ways that kops does it. For example, so kops creates the load balancer and then creates the certificates. Another way is to give it a DNS name and remap the DNS name as it goes. Okay, so this, that actually, so the machines API is another API which we talked about actually in SIG cluster lifecycle this morning. The cluster API, the machines API. So one of the nice things there will be something that hasn't really happened before is, so if you have a master control plane, it will make it easy to bring up nodes, and it will effectively have a more standardized way of doing the kubelet TLS bootstrap and the just bootstrapping of the nodes. But yeah, I think kops, for example, does not use a certificate on the kubelet still. Don't quote me on that. But it's. No, that was my mistake. That was my getting confused about the master. Oh, in front of the masters? Well, you typically want a reason to put a load balancer in front of the masters is if you want a stable identifier for your master, so that you don't have to change your kube config in. Yeah. That was my mistake. Yeah, the putting it in front of the kubelet was my misunderstanding. So I think if there are specific issues like that, then it would be great to open issues and we can talk about them, or come to the Hackfest and we can try to address it, or use your product of choice. Very soon, or you can use. Yeah, it sounds like. So it's some sort of intersection of real soon now, soon, but not next week. So there we are. There we are. I'm sure there are lots of solutions that people can use. So, but I mean, I think what we do in the open source project want to address those sort of issues. Like, we don't want to be in a scenario where, you know, the answer is use GKE because it's the best one ever, right? Like, that is not the answer we want for Kubernetes. We want it to be that open source Kubernetes remains as easy as practical to install, and then the tooling and the value add of people there's plenty of value to be added on top, and we're not trying to make the core hard to install deliberately. It's just a matter of figuring it out and getting that PR in tonight.
Just following up on that, I was curious what you see as the direction of managing Kubernetes clusters. You know, as more cloud providers offer managed Kubernetes, do you see the role of kops diminishing, or I guess would there still be any benefits to managing your own clusters, bringing up your own clusters with kops?
Yeah, I mean, I think there are always. So I think it's very important that we have an open source installation tool that works well, and that it works, you know, in various environments. And we don't want to be beholden to like a particular provider's implementation, because if you want to try something new, then maybe your provider doesn't let you do that, and that's going to be a tricky scenario. You know, in terms of, it's not what we want in open source. I think for most people, you're probably best served by using the managed service. At least there will come a stage where you're best served by using the managed service of your relevant cloud provider, and I think eventually, of course, everyone will choose their cloud provider based on Kubernetes because that's the only platform that matters. But you know, it's that sort of. There will always be people also that have peculiar requirements. You know, security type requirements that will want to run their own things. But hopefully the managed services will be good enough. But I think it's super important that we have open source options as well. I think for kops specifically, the goal is to make. Like, kops bundles a bunch of decisions together in terms of like etcd management, add-on management, machine management, even like how you install load balancers and things like that, and certificates. And it would be great to split those out and make those commonalities of open source, whether that means that we use the kops add-on manager or some other add-on manager. And then kops itself will become a very thin tool that hopefully the entire community of you know, all the Kubernetes installers will use the same add-on manager, so that you as a user have the same experience regardless of which one you choose. But yeah.
Hi.
Oh, question. Oh, sorry, Nish, you wanted a quick.
Well, I just wanted to add that it would be fair to say that
Right, so access to, Nishi said that access to the control plane on all the on all the managed services, at least on Azure and GKE, Google, and Amazon, is restricted, and so we definitely want to continue to allow to have an open source option so that you can develop on there.
Okay, hi everybody. I have a question regarding load balancers, which is, I think, mainly to the AWS team. It's like the Elastic load balancer have cryptic names, which makes it very difficult to monitor them. Is this changed with the NLBs? Are the names then chosen or still randomly?
It's actually, that's not your fault. That's my fault. The the name of the ELB is the letter A, and then the UUID of your service.
Ah, okay.
So it's not cryptic. It's the ID of your service. But the reason, and there is an issue. There's at least one issue, but there's one issue which is sort of like had some active discussion about this. It is unfortunate. The name, we do tag the ELB with the name of the service.
I saw that.
Which is at least better, and there are some tricks to make that show up in the control panel, and it would be great if it showed up more prominently. So for example, EC2 instances, the name shows up as the primary identifier, whereas that's not the case on ELB. So that would be a great thing to address in the control panel. We've also talked about trying to tag it with a name or with some hint as to the name, or like, the name prefix and then a bit of the UUID.
That would be great.
The two challenges there are, you have to choose a rule that doesn't lead to collisions, which isn't too hard. But the other challenge is, what do we do about the existing load balancers when you turn this on? And how do we sort of associate them? So if you can solve those two things in an hour and 20 minutes tonight, then that is wonderful.
Okay.
But that is,
Thanks.
but yeah, we're very open to doing it, but those are the two things we really have to address.
Thanks.
Thank you for carrying the mic around.
So, where we should be, or on which stage of our Kubernetes cluster we should stop using kops and start creating the cluster by ourselves. For example, if we're using Amazon with provisioning everything with Terraform, and to put our logic to deploy the whole Kubernetes cluster inside these instances. I mean, where we should be, what we have to need to start to doing this.
I'm not sure what you mean by that.
I think if I can rephrase, I think he's saying running Kubernetes using Terraform
No.
That's an interesting question.
Yeah, that's interesting one. But the question is, for now we have some workloads. We are deploying the cluster with kops. We're in AWS, but we need some custom things which we want to connect some custom things in AWS that kops will not provide. And the question is, what we need to have in order to stop using kops and just to implement the whole logic of kops by our own.
Yeah, so I mean, kops today can generate Terraform, so you can sort of, I think, I'm trying to remember what I think like there's a React thing where it's like it's called ejection, right? Where you sort of like opt out of the management process. You could start with kops today, get a Terraform thing that's a good starting point, and then go from there. I think what I think is probably better in general is to like share where it doesn't work, like share it in the form of issues and see if we can address it. And the hope of one of the things that I found works well is you can have kops you still run your cluster, you still create your cluster with kops, you create you manage the cluster objects in kops, you export Terraform, you apply it yourself, but you continue to do that as updates, new versions of Kubernetes come in. And then you can do things like you can reference the VPC ID and the security group ID. So for example, if you're creating an RDS database and you want to plug that in, or if you want to have two clusters and you want to like plumb a VPC interconnection between them, you have the two VPC IDs. So there are approaches you can take with kops, and I think we should do a better job of documenting them and figuring out what the barriers are. Yes, so that's what I've seen a lot of people do. So they will create a submodule which has a Kubernetes cluster in it, and that submodule is managed by and created by kops. And the nice thing about that is that then, if for each update you get a newer Terraform manifest, and you can do that. And it's because it's a separate directory, it's sort of you don't have to deal with conflicts. Whereas if you change the Terraform directly, it's messy. Something that's coming, which is very exciting, is the service catalog or the service broker API. And what that will let you do is, using the one true API of Kubernetes, you will be able to create, like imagine in future, the idea is that you can create a database as a Kubernetes object, and it will go, the service broker will go and like provision it from wherever it's coming from. So this is something that Pivotal started, and so I think they're talking about, I'd imagine that Amazon has or will have a RDS plugin so that you'll be able to get RDS databases in that way. And so, that's more about bringing it into the cluster, which I think is a nice way to do things, because then you don't have to deal with Terraform for everything, but everyone has their preferences. But that's certainly one to think about in the future. Is like the service catalog, I think, is ready-ish to use today or will be soon, and is a nice way to manage resources, effectively provision resources and associate them into your cluster. What it doesn't do is the scenario I talked about where you have like 2 clusters and you want to interconnect them, and that's where you really have to get into the tricks of like Terraform type management, or just a little script often will be proportional.
I just wanted to add that trying to re-implement all of kops yourself using Terraform is like, I think, a path to Trail of Tears. I mean, just like, and I've done this now, so we of course had to build all of this for EKS for our service, but my previous job, we built an entire framework to do this. It's a lot of work, and if you try to re-implement it, you'll immediately start tripping across things like there's going to be a new executable in 1.12 that you're going to have to worry about, and you have to worry about like which versions of etcd and match up with what, like there are a lot of sharp edges in there if you start trying to rebuild all that tooling that the community has been kind of learning and is pretty well tooled up to cope with at this point. So.
And the hope is that we get better there as well, that
Yeah.
it becomes less of a kops or nothing type scenario, or kops or EKS or nothing type scenario, right? And that it becomes much more manageable to do that yourself with the Machines API. If you can pull out etcd management and add-on management, then it will become much more practical to do that. But yeah, as Bob says, for now there is a lot of logic in there.
It'd be much more productive to get involved upstream and help. Like if it doesn't do what you want, help fix it. You'll get your job done much more efficiently.
Cool. I don't know if anyone else has any other questions. How are we doing on time? Are we okay? I don't know. I don't know if.
Well,
the Machines
I think
API
I'm on
is
safe ground by saying like that's probably not that scenario is not probably common enough. I would like to see the reverse, where like one of the reasons you use a system like kops is to be like opinionated about a bunch of things about the cluster, but then to actually use the hosted control plane. So like that would be another interesting thing, and I expect we'll see kops evolve in that direction.
Yep.
in a variety of ways too.
and that the other, like, to riff on that is like the idea of the Machines API, which is once you have a control plane and you have a machine controller, bringing up nodes should then be easy, is the theory. Getting that control plane is likely to remain challenging because of etcd and the work around that, but from a control plane with a machine controller, adding nodes should become much easier.
For masters, probably. For nodes, definitely.
And I think kops recently added support for Amazon System Linux too, so that's going to be good because we don't have to maintain the drivers, for example, anymore on our images. I'm thinking we're likely to adopt that more, particularly as EKS presumably makes even more optimized images. If that's, I don't even know if that's needed, to be honest. But System Linux 2 seems like a good.
I think I'll say optimization is a good thing, but I think the bigger benefit there is security patching. We keep up with all the security patching as part of Amazon Linux. So it's and by the way, we just announced our LTS on that as well. So Amazon Linux is LTS and available for on-prem both. So
System
I say
Linux
all that
1 or 2.
I'm sorry, 2.
Yes.
Yeah. So I think that we're very serious about making sure that that's a very secure option. So.
Yeah, and we're definitely going to try to support that in kops, but mostly out of laziness, because it's a great way to avoid having to do all that work and not.
So, I mean, last time we looked, there was no CSI kind of EBS. Is that thing where AWS is working on
So here I think is so I'm relatively new to Amazon, so I've been at Amazon since January. We are trying to operate a little bit differently than that now, especially around Kubernetes, because we're operating as contributors and upstream. So on these projects, we are very interested in not like dumping something in at the end, but in trying to do this work in the open. So if you're feeling like that's not the case, then please come talk to me. I'd like to hear about it. But that's like the CSI is definitely one of the things that we want to see show up and work.
Yeah,
We want to be working together with the community, not dropping stuff in.
I think one of the barriers there has been just figuring out whether that lives in storage or whether it lives in Amazon. I think that's probably one of the reasons, so that might be my fault. But
And
we're actually,
and we actually, there's been like a bunch of like hallway meetings on exactly this topic today.
there we go.
So like things are a little bit in flux.
We're actually at
So,
time, so if
yep,
if we want
anyway.
to continue this conversation, we can. I think there's more stuff happening, and thank you so
Great.
much.
Thank you, Justin.